Welcome to the first session of Quality Management Principles. In this session, what we are going to look at are broadly these topics. The first is going to be case tools, why case tools are useful. We are going to see why are they used so widely in systems analysis and design. That's about the case tools. The next topic we are going to look at is the data flow diagrams, the DFDs, data dictionaries, and the process specifications. Now these are graphical and text-based tools which came before case tools, but they're also very important tools, and they form the cornerstone of structured system analysis and design. The third topic we're going to look at is software maintenance. Now this again is a very, very important topic, though it is probably not given as much importance as analysis or design is given, but it is important and we're going to spend some time in looking at it. The next topic we're going to look at is a fairly new field of software configuration management. Now what exactly is that, what is its use, how is it different from software maintenance, all that we're going to look at. The last topic, in case we have the time for it, is object-oriented software technology. Now this again is a very, very vast topic. We'll probably need to spend one entire session on it, though we don't have the time for that. So we'll try and touch the aspects of it as far as possible if we have the time. So to start with, the first topic is case tools. Now what exactly are case tools? Case tools are, to give its full form, computer-aided software engineering tools. Why do you use them? To paraphrase the question, why do you use tools at all? Let's think back about the time before the photocopier, before the photocopy machine. When somebody had to make multiple copies of a particular document, what do? He just had to write the whole thing down by hand, again and again and again, as many copies as he wanted. This of course resulted in errors, it resulted in mistakes, it resulted in boredom, and a general feeling of what am I doing. Then came photocopiers. That made life much easier. If you wanted multiple copies at a touch of a button, you could get identical copies as many as you wanted. So a photocopier is a tool which helped the duplicator, in the sense it helped him to make his life easier, it helped him to get number of copies easier. So tools are always important to make life easier for the person concerned, to make sure that the job is done faster, in a more efficient way, in a better way. Computer-aided software engineering tools or case tools are used in exactly the same way. They're used by systems analysts for designing systems better, for making their work easier, for making their work look better, more presentable. Now case tools can be used either in a standalone mode, which means you can use only a single case tool at a time, just use that case tool for its purpose, and that's it, don't use anything else. But the true power of case tools will come only when you integrate them in the proper environment and if you're able to port them across systems. What does all that mean? First thing, the proper environment, which means you must have a proper hardware system, you must have a proper systems, software systems. For example, in hardware, you must have a proper, a powerful hardware, not a powerful machine, which is going to be able to handle the tools properly. In the system software, you must have a competent software, which again is able to take care of the tools, take care of what you are doing. Then you must have integration routines. In fact, there are specific integration routines which integrate or which combine two or more case tools together. With that, what happens is that the individual capacities or individual capabilities of the case tools is enhanced. So you have a manifold effect, a multiple effect of the case tools. Again, the true power of case tools also is achieved if you can transfer them or you can port them across operating systems, across hardware platforms. So you need the correct portability features. So if you want to really use case tools, really want to use the true power or the real capabilities of the case tools, you must have a proper environment, the hardware as well as system software environment. You must have the correct integration routines, which will help you to integrate two or more case tools together to get a better effect out of them. And thirdly, you must have the correct portability features, which means you should be able to port these case tools from one machine to the other, from one operating system to the other. Now, there are a number of case tools in the market. In fact, there are so many of them that it will be almost impossible to even start thinking about talking about each one of them. What we will do now is we are just going to give you a brief look at some of the types of case tools. Now, this list which we have authored was 3 types which we are going to discuss just now. This is definitely not a comprehensive list. There are many more case tools in the market. In fact, many of the vendors, their sole job is to prepare case tools for systems analysts. So, you can see the amount of case tools which might be there in the market. Which case tool we are going to use depends on the project, depends on the need that you have, depends also on the finances that you have, depends on a whole lot of other considerations like the organization's policies, so many things. So, we are not going to look at any specific case tool, we are going to look at certain types of case tools. The first type of case tool which we are going to see is project planning and management tools. Now, you know that in today's world, project planning and management is a very crucial task. Mainly because projects have become very important, they've become very critical, they've become more expensive. So, managing a project is one of the probably the biggest responsibility of a systems analyst. You have tools which help you, case tools which help you to schedule the project, to outline the path that the project should take, to define the events and the tasks that are supposed to take place in the project. After the planning tools, you also have project management tools which help you to monitor these tasks, monitor the events, make sure that they are working in sync with their supposed working, make sure that they are working the way they ought to be working. If there is any lag, then try to explain the lag, try and see how it can be corrected, etc. So, these are the project planning and the management tools. Another type of tools which you can have are the risk analysis tools. Now, here again, because of the large size of the projects, because of the critical nature of the projects, the large amount of financing which paid to a project, the amount of risks involved in the projects are also much higher. So, if you need case tools which will try to pinpoint these risks, try to identify those risks, and then try to monitor them or try to contain them, try to make sure that these risks are identified at the earliest stage possible, so that you can minimize them, or you can probably make sure to do something to eliminate them totally. So, you have risk analysis tools. The third type of tool we are going to look at are the documentation tools. Now, documentation tools are very important because documentation itself is very important. On an average, a systems analyst spends about 20 to 30% of his time on documentation. So, documentation has to be done very completely, very clearly and very carefully. Now, why should it be complete? It should be complete because if the documentation is incomplete, there will be some gaps in it, and at the end of the project, the user is bound to put his finger right on that gap and say, this is something which I wanted in the software and I don't have it. So, documentation has to be complete. It has to be done very clearly. Clearly because documentation is not a one-man job. Project itself is not a one-man job. It's teamwork. And each and every member of the team must understand clearly what the project is all about, what the user is saying, what the analyst is understanding. All this has to be made clear to each and every person in the team. So, therefore, documentation has to be so clear that each and every person will understand what he or she is talking about. Lastly, it has to be done very carefully. Now, documentation has to be done carefully because any mistake at the documentation stage is going to be magnified or multiplied into a very major mistake at the end of the project. It would be better if you spend more time in documenting the facts very clearly, very completely, very carefully in the beginning, rather than waste time doing frantic repair work at the end of the project. So, therefore, documentation has to be done completely, clearly and carefully. To help you to do that, a case tool is almost a must now. Of course, it is possible to do all this manually, by hand, or even by using a simple word processing package, but a case tool is, in today's environment, is almost a necessity for documentation. This is about case tools. The next topic which we are going to look at are other graphical and text-based tools like DFDs, that's data flow diagrams, the dictionary and the process specifications. Let's start with the DFD, that is the data flow diagram. Okay. Now, what exactly is the data flow diagram? A data flow diagram is a graphical technique that depicts information or data flow and the transforms that are applied as data moves from input to output. Now, what does that tell you? Let's go through it again. A data flow diagram is a graphical technique, which means it is made up of pictures. It does not have too many words. It is not a textual document. It is made up of pictures, diagrams, figures. So, it's a graphical technique that depicts information or data flow. That shows how data is transferred or how data moves or how the data flows, how the information flows, and the transforms that are applied as data moves from input to output. It shows what are the processes which work on the data, which are applied to the data as it moves from the input stage to the output stage. So a DFT is a pictorial representation of the system, of the processes that work on the data, that are applied on the data as it comes as the input and goes out as the output. A DFT is also known as a bubble chart. Let's see why. Before we go into the bubble chart, let's see some of the basic notations about data flow diagrams. Now, the beauty of a data flow diagram is that the notations are very simple and they're very few. So even a totally computer illiterate person can understand them immediately. So let's look at the notations. The first notation you have is a rectangle, which is the notation for an external entity. Now, this external entity could be an organization, it could be a machine, it could be a person, it could be another system, it could be anything. It could be anything which is in no way connected or which is not part of the system that you are considering. Okay? It is connected to the system that you are considering only with respect to the inputs that it sends to the system or the outputs that it gets from the system. So it's totally external to the system which we are developing. The next notation that you have is a circle. The circle denotes a process or a transform. Now, we have talked about earlier in the definition that a DFT shows or depicts processes that work on the data and transform it. So a circle indicates that the input is coming into the circle, is being transformed, is being worked upon within the circle, and the output is going out. So a process is denoted by a circle. The next notation which we have is an arrow. Now, the arrow tells you that it is a data item or a data flow. Now, the arrow out here is extremely important, obviously, because you have to indicate the direction in which data is going. Remember, we talked about the DFT is a pictorial representation of the data movement, of the flow of data. So therefore, direction is very important. You have to know where data is going, from where to where, from A to B, from B to C. The direction is important. So the arrow has to be there. Okay? It tells you the direction in which the data is moving. The last notation you have is a data store. That tells you this is a store of data, a repository of data. It can be equated to something like your physical file or a filing cabinet or notebook which contains all the data. So as a static store of data. These are the only four notations you have in a DFT. So it's very simple. Anybody can understand it. Okay. Now, after you get the notation straight, let's look at the starting point of a DFT. The first thing which you draw in a DFT is the context diagram. Now, what is a context diagram? A context diagram shows you one single bubble. That is why a DFT is called a bubble chart. A single bubble or a single circle which depicts the entire system. So here in this slide that you see, process 1.0 shows you the entire system that you have. Okay. The inputs to the system are input A, B and C. Outputs from the system are output A and B. Now, these inputs are coming from some external entities. Outputs are going to some external entities. We are not concerned with those right now. What we are concerned with is that the context diagram is the first level or the first diagram of a DFT. It means that the system is denoted by a single process. Then you have something called top-down partitioning. Now, what is top-down partitioning? We have talked about it earlier in earlier sessions also. What this means is that you take the first level and you break it up into lower levels. For example, let's go down to level 1 DFT. We had process 1.0 earlier. That has been broken up into process 1.1 and process 1.2. The inputs are the same, the outputs are the same. This is also called balancing of DFT, which we'll come to it a little bit later. So, the DFTs are now broken down. They are partitioned. This is a level 1 DFT. Now, process 1.1 can be broken down again into further levels, maybe 2 or more or any number. Then process 1.2 can be again broken down. So, this process will continue. It is an iterative process. Now, where do you stop? That is a tricky question. Because if you stop too soon, then the lowest level of DFTs become too complicated. They're still not very easy to understand for the user. He won't know what's happening. If you go down too much and you make them at a very low level, then the lowermost DFTs are too simple and the number of DFTs become too many to manage. So you have to draw a fine line where to stop the partitioning. Ideally, is to stop the partitioning when the last level of DFTs becomes simple enough for a user to understand. That's the thumb rule. Okay. Now, what you must remember, very critical, in a DFT is the DFT indicates only the flow of data. Remember that, only flow of data. There is no indication in a DFT about the decision points or the iterative procedures, that means whether it's repeated. There's no indication about the sequence of events. You don't know whether process 1.2 is following process 1.1 or not. There is no indication about system behavior. You don't know the frequency of transactions, you don't know how the users are handling the system, you don't know what the problems are, nothing. Okay, it just indicates the flow of data. So you must remember that about DFTs. We talked about balancing of DFTs. Now how do you balance DFTs? What you have to do is balance the inputs and the outputs while partitioning DFTs. Remember we talked about the context diagram? All the inputs and the outputs will be there in the context diagram. Those should be retained while going down to the lower levels. What this means is that you must not introduce any new input or output at the lower level if it is not there at the higher level. So no new input or output can come in at a lower level. All inputs and all outputs have to be identified, have to be defined at the context diagram level first. That is known as balancing of DFTs. Now you will appreciate the importance of a case tool here, because in very large systems where you have hundreds of DFTs, balancing a DFT can be an immense task, and this is where case tools will help, because they will do it automatically. Okay. We talked about DFTs, data flow diagrams. The next thing we will look at is a data dictionary. Now what exactly is a data dictionary? A data dictionary is used to define the system clearly and precisely. A data dictionary is, like any other dictionary, a compilation of all the terms, words, data stores, data flows, etc. used in the system. But why do you need it? Why do you need a data dictionary? See, you need it because a DFT or data flow diagram will only tell you the flow of data. It does not define the data. It does not tell you what exactly the process is all about. It does not tell you exactly what the data store means. You may have a data store called invoice. Okay, now does this mean the bill which is being sent to the vendor, or does it mean that a bill which you are getting from the vendor? What does an invoice mean? That has to be defined clearly. Okay? So a data dictionary is required to provide a standard terminology that is easily understood by the whole team. The terms should be self-defining and partitioned. Now what does that mean? So when you define something in a data dictionary, it should be self-defining. What that means is that there should be no ambiguity about it. It has to be clear, something the entire team can understand. For example, suppose you define something called overtime pay, which will be defined as the overtime hours worked into the overtime rate. Do you think that is enough? No, because you don't know what overtime hours are. You have to further define or further break down the overtime pay and define overtime hours as the total number of hours worked minus 40. 40 could be your regular hours. So at that stage, when you define the overtime hours, at that stage it becomes self-defining. You can't break it down any further, and it becomes very clear. Okay. The next thing a data dictionary is required is, because it defines clearly individual processes, data stores, and data flows. Okay. So all this we've already said, that all these things should be very clearly defined, mainly because each and every person in the team should understand the whole thing completely. Why else is a data dictionary required? Another main advantage of a data dictionary is that it provides different types of listings. It provides an alphabetical listing to eliminate duplication. For example, if you've used the same type of phrase more than once, if you have an alphabetical listing, it will tell you immediately. It will also give you a cross-reference listing. Now, cross-reference listing is a very useful tool which is used by many analysts in data dictionaries, because it gives you a cross-reference of which data item is used where, which data item is used in which process or which data store or which whatever about it, where is it used, how is it used. This helps because whenever there is a change, whenever you want to make a change to any particular item, you can immediately identify that if I change this item, this is going to get affected. Normally, though it may differ in different case tools, the format of a data dictionary would be you have the name of the particular data item, you have the alias. Now, alias could be just in case that particular data item is used is called by any other name. Just in case, and the alias tells you what other name is used for that. Yeah, then you have something called the where used and the how used. Okay, where is this particular data item used? How is this particular data item used? You have something called the content description. In case the name is not self-explanatory, then that content description tells you something more about the item. You have some additional information, maybe some special information about the item, like say some boundary conditions or something like that. Let's see an example of what exactly it is. Let's see, the example is where in the name you have the years in the company. That's YRS_IN_CO. There is an alias also, which is YRS_WRKED. Where is it used? It is used as an input to the employee details process. Is there any extra description? Yes, the description is it is number of years that the employee is working in the organization. Any additional information is that the maximum value for this field can be 25. Probably because the organization was started up only 25 years back. So obviously an employee cannot be working for more than 25 years in the organization. The next thing we are going to look at is the process specifications. Now we talked about the DFDs, we talked about the data dictionary. We've also seen that DFDs break down the system into the lowest level of processes. But what exactly is happening within those processes? The DFD does not tell you that. The data dictionary doesn't tell you that. The process specifications, the mini specifications, those tell you that. So what exactly are process specifications? They are the statements written in structured English to describe the function to be performed or action to be taken by the different processes in the DFD. We've said that there are DFDs and broken down into the lowest level of processes. Now all the actions which are taking place within those processes are defined very clearly, concisely in structured English. Structured English means English which is is not verbose. It is to the point, precise. That is called structured English. What should process specifications be like? Are there some guidelines to writing them? Yes. The guidelines are that the process specification should be concise and to the point. They should not be verbose. They should not be going here and there. They should be absolutely clear and to the point. Action verbs should be used like move, open, close, etc. You should totally avoid relative words like faster, better, good, improve. All these words should be totally avoided because they don't mean anything. Then the rules and conventions for this writing of structured English should be finalized before the beginning of the project. Now this is something which is very, very important, very crucial, because what happens is each and every person in the team uses his own type of structured English. See, structured English basically is a kind of shorthand. So, which is fine, you should have a shorthand for that, but the point is that the entire team should have the same shorthand, not every individual. A person may feel that something which he understands is easily understandable and self-explanatory and does not need to be told to other people, and there does not need to be any rules or conventions for it. But let's give you an example. Suppose a person wants to say that if the overtime is more than 24 hours, then the supervisor should review the time record. That is what he wants to say. If he writes it in structured English as if OT greater than 25, review TR. What does that mean? Who knows that OT is overtime? Who knows that TR is the time record? So structured English norms, rules, conventions must be finalized before the project starts so that each and every person understands. The same thing should mean the same thing to everyone else in this team. Okay. Let's give an example. Now, suppose you want to, the process says that you must not process the customer's order if his past dues have not been cleared. One way of saying it would be hold customer's order till past dues are cleared. Now that does not tell you anything, does not tell you what actions to take. The correct specification would be if order is greater than ₹10,000 and if the dues are greater than 60 days overdue, then hold the customer order, else process the customer order. This is the correct form of structured English and the correct mini specifications which tells you exactly what action is to be taken. Okay. We've seen so far case tools, we've seen DFDs, data dictionaries and process specifications.